something very square or very rectangular. It's always got to be, we always got to put our dictoth. Do you guys know dictoth? Okay, sorry. Old professor here. You got to put your dictoth influence on the landscape, or your Jerry Furman influence on the landscape. We got to have these nice curvilinear designs and something crazy. And so we get really odd shapes in the landscape where we have different size areas that we're irrigating, and they might have primarily the same material in them, but when we change our sizes up of the area that we're irrigating, it becomes very difficult to irrigate that efficiently. So drip lends itself to odd shaped areas very well. Okay, this is one of my great designs, grass in a parking lot with spray heads right behind the back of the curb, so that when that comes on, that the cars block the sprinklers. It's, you know, it's just the real world out there. We run into some really unique areas that we're dealing with. Flower beds, they're always very difficult to irrigate because they tend to grow over a large area and can block our overhead irrigation that we're trying to irrigate with. And so drip fits that fairly well. Okay. The other advantage with drip irrigation is that we tend to run into a lot is vandalism. We always see the spray heads where the water is shooting up out of the ground, or the rotors that aren't turning or something like that. We run into that a lot, so vandalism. We always are trying to put a buffer up next to a building to soften that building a little bit. And if we're using overhead irrigation and we have glass up there, as designers, one of our responsibilities is to try to take a look at that as we're designing our landscapes and we're looking at the design part of it. The thing that we need to be doing is we need to be thinking about the other aspects of the project that we're looking at. We got to irrigate that. We've got to fertilize it. We got to maintain it. Those kinds of things. So as you get more experience in the design side of it, you will, especially when you get out into a real firm and you start practicing, you'll start thinking of some of those things, because your clients will ask you those questions. Okay. And then overhead spray. You know, here, this is a classic example, you know, where we get a lot of wind drift and runoff. This is a brick on sand sidewalk that they paid a lot of money to put in, and because that water is running over across that brick on sand, we can start to see there's a lot of settling going on, some low spots that are happening in there, and they had to come back in 2 years after this and rip that out and put in concrete. Just great design, but it just didn't fit with what they were doing there. The maintenance of it was painful. Okay. Another one of my designs, the 4-foot piece of grass between the sidewalk and the fence. You know, this is my classic design right here. Kidding, but you know, we got to irrigate this. You know, so it might look good on plan, but we need to step back a little bit and take a look at the maintenance side of it and go forward from there. Okay. So what are the applications when we talk about drip irrigation? It's pretty, I really haven't ran into too many areas where we can't use drip irrigation. There might be a few of them out there, but for the most part, if we're growing plant material or we have grass areas, unique areas, odd-shaped areas, large areas, we can pretty much drip irrigate it and use the water savings. Now, the application is there, but there are other things for cost and long-term maintenance that might cause us to look at some other applications from an irrigation application, okay? So what is drip? And I've got some examples here today. We're going to kind of go through this, and we'll go through the design part of it, and then we'll probably take a time out. We'll look at some of the products. We'll kind of do a hands-on, and then afterwards we'll show you some examples of what we're doing, and then I might have you break out your HB pencils and some paper, and we'll do some designing of some systems right on the back of your notepad there. So there's basically two forms of drip irrigation that we're looking at. One is an integral dripper line, which is this right here, and we'll take a look at this a little bit closer. This is a 250-foot coil, And basically is what happens is the manufacturer puts the emitter in the tubing already. Okay, they all have the same flow rate. They're spaced at a very uniform distance. You either get them at every 12 or 18 inches, and then they have different, the same flow rate within the same coil. Very low maintenance. This is the trend of where people are moving on drip irrigation. The other part is what we call point source areas, where we have the little button emitters, like these right here, where you lay your tubing out and you punch in the emitter and then the water drips out right there. And I got some examples of what those look like right here. And basically, they're for wider space plants. So when we have an area where we have 2 or 3 shrubs in there or something like that, we're trying to irrigate that. It doesn't make sense to irrigate a larger area. Arizona, we think a lot of Arizona when we talk about these type of applications. Okay. The inline dense planting ground cover area is turf grass. We irrigate grass with this stuff, subsurface, below grass. We'll show you some examples of how to do that. Planter boxes, tree rows, medians, large planting beds, highway projects are pretty good for the inline tubing. Okay. So the inline tubing, on this side of it, just so that you know, the emitters are pressure compensating. So pressure compensating is a basic feature that most drip products have, but it is something that you need to look for. But basically is what it means is you take your tubing and you snake it out through your shrub bed, and the water comes on and it has pressure. No matter what the pressure is on that line, all of the emitters will put out the exact same amount of water. Okay, so I don't know how much irrigation design you've had yet or where you're at. Hopefully you've calculated pressure losses and those kinds of things. Okay, so we know at the beginning of the line we're going to have more pressure, and as we snake that tube out through the end, that our pressure is going to be lower, right? With pressure compensating, is what that means is as long as we have a minimum pressure on our drip, and usually it's somewhere between 6 and 15 psi, that no matter what that pressure is, it could be 16 psi or it could be 55 psi, that emitter is going to put out the exact same amount of water. Okay? With our overhead irrigation, that's not necessarily the case. With our rotors and sprays, the longer the distance that we go, the less water that those far heads are putting out. Okay? Then anti-siphon feature, I'm not going to get into that. It's continuously self-cleaning, I won't get into that. Check valve, there is a check valve. Not all emitters have check valves, but a check valve is like a SAM feature. If you talked about some heads of what they do, is basically is what happens is once the tubing or the emitter fills up with water and it starts putting out the water, when the valve closes, then the emitter will shut off and not allow the water to drain out of the tubing. Okay, not all drip products have that. Some do and some don't. Okay, I will talk a little bit about continuously self-cleaning, because one of the concerns about drip irrigation is that they plug up with dirt fairly easy, and some do and some don't. Some of the things to look for when you're dealing with drip irrigation is the level of filtration that they require for operation. The more filtration that a drip product requires typically means that it's going to plug up with dirt easier. If a product needs less filtration, to where it allows some dirt and debris to go through it, then it tends to mean that it can handle dirtier water. So those are some things to look for in drip, and there is a big wide variance on the filtration requirements for different products. Continuously self-cleaning emitters are emitters that, while the water is flowing through it, dirt can, let's say a line breaks, dirt can flow into that emitter, and continuously self-cleaning means that if dirt gets into the emitter has the ability to kick that dirt particle out of it and not clog itself. If it's just self-cleaning, it's only going to do that when the emitter first turns on and then when it turns off. While it's running, it cannot do that. So the key word to look for is continuously self-cleaning. Okay. And then the flow rates, 0.26, 0.4, 0.6, 0.9. In drip, we talk a lot about in gallons per hour, okay? Instead of gallons per minute, because we're applying the water slower. And then our emitter spacing in the tubes, the emitters are every 12, 18, or 24 inches. And then our coil sizes, you could buy the coils of tubing in different lengths based on the size of the project. Okay, yeah.
So is that, those flow rates, is that coming out of each hole or?
Yes.
Okay.
Yeah. And
if I have 1,000 feet of drip line.
Yeah.
And it's got that 0.6 would be 250 gallons every hour.
So we'll go through and show you how to calculate that, okay? I'm going to pass these around. These are just samples of the tubing with the emitter inside of it, just so that you can kind of see what they are. And you can, if you guys can just open that up back there and kind of work it back that way, that would be great, okay? So how many of you guys have taken soils classes? Do we have a lot of soils gurus in here? Do we know what a tetrahedral sheet is? Okay, just thought I'd ask. We had to take soils classes when I was here. Okay, so when we talk about drip irrigation, this is a foundation slide that really talks about why drip is growing at the speed in which it is. And these numbers here that I'm showing are from CIT, the Center for Irrigation Technologies. I'm going to pass these up back here. Inside of these bags there's some emitters that aren't in the tubing, so you can kind of see what the emitters look like. Okay. So when we talk about efficiency, okay, a spray head is somewhere between 35 and 60% efficient. A rotor is 45 to 70% efficient. Rainfall is somewhere between 92 and 95. And drip irrigation is somewhere between 92 and 98% efficient. So when we say a spray head is 40% efficient, here's a quiz. What does that mean? Anyone want to take a guess or a stab at that? Okay, so when we look at the efficiencies, we took a look at DU, distribution uniformity. I'm not going to cover DU in this class. Someone else can cover that. But basically, when we have a 40% efficient sprinklers, what that means is 60% of the water coming out of that device, like a spray head, 60% of that water never makes it to the plant material for consumption. And primarily it's because we throw it in the air. When we throw it in the air, then it's affected by wind, temperature. The other challenge that overhead irrigation has is as soon as you throw water 3 feet in distance, physics takes over, and it means that we have to use so much pressure and so much volume of water to throw at that distance that the water coming out of there is faster than in which it can move through the soil, and so we get a lot of runoff. So with overhead irrigation, we get a lot of wind spray and a lot of runoff because of the rate in which we're applying it. Rotors, 45 to 70%, and drip, 92 to 98. So if we take a look at this, and we look at the low end of drip and the high end of a spray head, if we were to convert a spray head system to a drip irrigation system, we should realize 32% water savings immediately without doing anything else, just by not throwing the water in the air and or the runoff. Okay, does that make sense? Any questions about that? Okay. The other advantage that we have with drip irrigation is that it operates at a lower pressure. These emitters, the point source emitters, are designed to operate at 6 PSI. So if we have 6 PSI or higher, then they're functional. On the dripper line, the pressures are somewhere between 6 and 15 PSI to operate. So when you take a look at that compared to a rotor, that's irrigating an athletic field, they typically need to be right around 50, 60, 70 PSI to throw those distances that they need to. And so if we're on city water, it's not such a big deal, but if we need a pump station to where we're pumping the water, then we have electrical demands that are being used on that pump, and in some places they're using engines, and diesel engines, and so then we got the cost of fuel. So as soon as we start looking at that, then it becomes very expensive on top of the cost of the water. Okay? No overspray, as we saw before, because we're not throwing the water in the air. The water is not running off or being affected by the wind. And then no water window. Drip irrigation, we can typically irrigate whenever we want. It does not tend to fall within the water restrictions that cities apply, primarily because drip is so efficient. They allow us to irrigate whenever we want. We're not throwing the water in the air, and that helps. Okay. So we're going to talk a lot about the inline tubing today, primarily because that's the movement. That's where most of the drip irrigation is going, or is currently, and it's growing stronger. The point source, not so much, primarily because